Is there anything new with architecture and design? Well, let's take a look. Today we'll look at InfoQ Software Architecture and Design Trends Report from April 2025. Welcome back to Think Design Work Smart. I'm Bolboaca and I'm coming at you from the Mozaic Works studios. And as I said, today we'll take a look at this report that was published on April 28th, 2025. This report is created, I guess, by Thomas Batts, Laureate Application Architect at Blackboard, and Sarah Wells, former Tech Director for Engineering Enablement at the FT. I assume that's Financial Times. I don't know. Anyway, this is the Software Architecture and Design Trends Report. We've done reviews of previous such reports. And usually it's a very interesting thing because we can look at the trends and talk a little bit about what's going on with software architecture and then compare with our experiences. So let's start. As usual, this report is split into a few the steps of adoption, and the steps are innovators, early adopters, then there's the chasm, early majority, and late majority. So late majority, these are technologies or techniques that are now widespread. Early majority, technologies or techniques that are spread but not as wide. Innovators on the completely left hand side are people who adopt new technologies or trends, and in this case is focused on the technologies and trends. So these are just coming in, and some of them will move forward, some of them will just fall off. And early adopters, these are innovative technologies and trends that are more adopted. So they found a core audience, but they haven't yet moved into early majority. Generally, early adopters are people who are very interested in the solution to that this technology or technique is presenting to them. And then there are a few details about this report. And if you want to read it, you can search for Architecture Trends InfoQ 2025. You can find it. The link is, as usual, in the description of this video. Let's see what we have in late majority. We have GraphQL, which apparently is pretty widely used. I honestly haven't seen that much GraphQL usage. Perhaps it's selective group from large companies, for example. Large language models apparently in the late majority, so many organizations seem to be using large language models. Honestly, what I've seen is that large organizations, at least in Europe, tend to shy away from this. They don't include large language models in their practice. Maybe they include them as ways to expose certain features, like for example chatbots, but they don't include it in the development process. So yes, you may find large language models with as part of certain features, but not necessarily in development because of privacy reasons and so on, security. So there are some good reasons here. They also mentioned the actor model at late majority, which is very puzzling to me. Who is using actor model? Not because it's not a good idea, it's a brilliant idea, but I haven't seen people using actor model. And actually, in in my latest book on C++, I wrote in a chapter about actor model, and it was difficult for people to get to it. So I don't know who's using it. It's a brilliant idea. It can probably replace microservices for certain types of applications with simplified operations and reduce costs, while preserving the possibility to split into microservices later on. It's also really good for parallel programming. So yeah, it's a great idea, but I don't know who's using it, honestly. Service mesh, this is a very good idea. It's more widely used indeed. Functional programming, late majority. I mean, if you look at the functional programming language features, like things that got into C Sharp and Java and Python and the mainstream programming languages and C++ and Rust. Well, you have lambdas now, you have all kinds of functional programming constructs, but I wouldn't call that functional programming, because functional programming is about a specific thing. It's about having immutable data, pure functions, and this leads to certain changes, and functions as a first-class citizen, which means that you can actually combine functions and so on. So when they say functional programming, I assume they are talking about having features in programming languages that are functional, and then libraries that support functional programming in programming languages that have these constructs but don't have those libraries. Serverless apparently is late majority, weirdly enough for many large companies that I work with. They tend to use their own cloud system, usually based on the IBM, the Red Hat one, OpenShift. So it's not necessarily serverless, it's more like Kubernetes style. So I'm curious who is the LA majority using serverless. Reactive programming, again, weird. HTTP2 and gRPC. gRPC, I've seen quite a growth indeed. HTTP2, yeah, it's coming, but because more and more servers are supporting it, it's easy to switch. So yeah, HTTP2 definitely lane majority. gRPC, I'm not sure. I mean, people are still doing REST APIs, right? So gRPC, you can do REST APIs with gRPC, but it's not the most common way I see. Event sourcing, again, interesting, good idea, but I haven't seen it that much in production. Maybe there is a data-driven companies, because event sourcing is a really good source for data analysis. Then early majority, they talk about platform architecture. I've seen a lot of articles on this. Not as much architecting, but it is a topic that's very discussed. Open telemetry, this seems to be catching on. As far as I understand, it's a standard for gathering and monitoring. And I think this is a very useful idea, because we really need to monitor our products, and having a standard is always good, because then you can have interoperability, you can have tools that are standardized and so on. AI assisted development, they say it's early majority. I mean, yeah, there are many startups, and particularly I think US, Asian companies that use this. I'm not sure it's that widespread in Europe. I'm curious. If you are a European software developer, do you use AI assisted development? Because many large companies, again, are kind of forbidding it for various reasons related to privacy, security, sharing the code, because your code might end up into other people's hands, and also you might generate code that is an actual copy of other people's code. So in this case, you are not compliant with copyright laws. And so there are a lot of things that you need to pay attention to. Micro frontends, yeah, I would say it's early majority, because many people who have done microservices have figured out that it's not that easy to do UI without it. And I've seen some talks in Europe about micro frontends. So yeah, architecture decision records, yes. Although they are not used as they should, but they are used more and more. And what I mean by that is architecture decision records should document architectural decisions. And because of that, they should document alternatives taken into account, decisions. And usually the best way to use them is by storing them in source control along with the other the source code, and ideally with the diagrams if you do code diagrams generated from code like PlantUML or Structurizer or Mermaid. But most of the times, as I understand, they are stored in Confluence, not maintained that much. It's not easy to see their history. And the whole idea with architecture decision records is to be able to, maybe not to fully recreate, but at least to get some hints on the history of architectural decisions in a project, particularly a long-term project. So this is why they should be easy to find, right? I doubt there are many secrets in ADRs. Maybe there are, but usually these are things that you should be able to share with your developers. Modular monolith, okay, that's good. Early majority, great, finally. Moving into a good direction. So these are interesting. I kind of doubt the late majority. Some of them, the early majority sounds fine. Let's see innovators. I don't know why, but I prefer to go to the left. Innovators, agentic AI. Yeah, that's the idea of having independent agents that do various things. And some of them help with programming. I think this is the main area where we are experimenting with agentic AI, but you could also do it for marketing, for other things. Sales, maybe. Now, the way I see it, agentic AI, the fact that we are getting agentic AI is proof that we won't get AGI very soon. The whole idea with AGI was that we'll get general intelligence which will solve all the problems much better than people can. And it's obvious this is not happening, which means that we are going towards more focused and more specialized intelligence, which is what I expected when I saw ChatGPT and the initial large language models. And this links to the second one in innovators region, which is small language models. So we actually now are looking into having small but focused language models that feed into agents. So more specialization, less general intelligence. And that's what I expect to be the trend in the next few years. I really doubt that the current approach and trying to scale up large language models will lead to general intelligence. We'll just have the need for specialized intelligence. Now, there's still a lot of work to do and many improvements that can be done to existing models, but I don't think we'll get at that point. I think large language models won't scale, and we'll need to apply another method to get to AGI, which will probably take decades. So I think we are safe for now, but still agentic AI with specialized language models will disrupt a lot of the work in software development, and not only. Imagine this. Imagine that you have a lot of issues or a lot of tickets in your backlog that relate to small improvements that you aren't able to do and maybe you'll never be able to do. Those are perfect for agentic AI because you can give them to agents. They will try to solve them. You come and look and verify, does this work? Was the validation added? Was the button made nicer, or whatever improvements you might need? And if not, you can always retry. And eventually, maybe you are lucky and you get to the point where it solves it for you. So this is one area, but other areas are places where we don't really need more specialized knowledge because, or you might need a specialized knowledge today, but it can be replaced with agents, like generating configuration files or Docker files. Or these are easy to verify once they are generated to see that there are no issues. And of course, you should know the domain and how to make one yourself. But then once you do, it's pretty easy to let an agent test the resulting image, verify the generated file, and this works quite well in my experience. It's really good. So as long as you know what you're doing, agentic AI, small language models with a human in the loop is a really powerful model that I think will disrupt the way we do software development. And I think the roles will be rethought because of this. You might see roles disappearing, merging into one another, and getting to better results faster. And also eliminating at the same time some of the work that we were doing, or doing more of the things that we never got to doing. So it's likely that software developers will need to focus more on the hard problems and less on problems like configuration files or where to put things or things like that. Now, It's also easier to generate tests. It's also easier to do test-driven development with these tools. So there are a lot of techniques that can completely change the way we do software development. And not only. Same thing might apply to marketing, search engine optimization, just to mention a few. Sales. Okay, privacy engineering. Now this is an interesting one. I think it refers to, let's see, privacy engineering was added to TrendGraph in 2024 to highlight companies that are thinking about privacy as a primary feature rather than something they are implementing in reaction to regulations or other incidents. Yes. So privacy upfront. I think this is most seen in Europe, but also due to the California laws on privacy. I think it's pushing its way to other areas of the world, but in Europe, it's really getting an important part. And in the same range, we have green software because it's still a non-functional requirement, so privacy and green, which means less carbon emissions, less energy consumption, and so on. Now, my thing with green software, the thing that I'm continuously thinking about is that it's quite difficult to measure yet. So it would be interesting to have some kind of combined metrics that come from the cloud providers, from data centers related to the green part. Because my feeling is we might say that, okay, this is easier to run, and we did a whole review and reaction to another article that was talking about green software on this channel. And they were only talking about the operational concerns, but the question is, what about the development part? Do we care about that, or is that not as important? Maybe that's just 2% and the operational part is 98%. I don't know. My feeling is that we don't yet have enough data, because here's a simple example. Let's say you replace Python with C++ because compiled software consumes less energy. And based on the reports I've seen, this is the case. Of course, it depends a lot on how you write the Python code, how you write the C++ code, but it's a different problem. Let's say you write optimized Python code, and let's assume that optimized C++ code that does the same thing will consume less energy. But now the problem is, what about the compilation? Because C++ takes a long time to compile. And you have maybe 100 developers continuously compiling C++ code. Doesn't that add up? Isn't that on par with the operational needs? So for green software, it's still a bit fuzzy what we want. Yeah, but I believe we will get to a point where we need to consider carbon emissions or least energy consumption as a non-functional requirement in our architectures. HTTP3, the next HTTP standard, it's still innovators, not many servers support it. It will take a while. I'm not sure how long HTTP2 took, but at least 5 years, so probably much more than that, much longer. And the apps, I have no idea about the apps. I know they are some kind of Web3 technology, but I have no opinion here. I've never used those. Okay, and now let's talk about early adopters. These are really interesting. We have cell-based architecture, and we did a whole video of what cell-based architecture is. Very interesting. I recommend you watch that, because you might find another paradigm that works for your architecture better than microservices. Retrieval augmented generation. This is once again related to AI. It's about retrieving data from APIs, from documents, and then using a large language model to generate stuff, text, diagrams, videos, whatever, based on documentation, APIs, web searches, and so on. Socio-technical architecture. This is something that we've discussed a number of times on this channel. Definitely important. I guess more and more people are realizing that architecture and development in general is not only in the technical domain, but it goes heavily into humanistic domain. Edge computing, another very interesting trend. I recently studied problems with architecture for drones. And this is where edge computing becomes very interesting, because think about it. When you have drones, you have basically flying computers that can go anywhere. And those drones have some sensors. And we'll assume civilian drones, right? Not military, civilian purpose drones. And those have some sensors. So let's say maybe you want to monitor your fields if you're doing agriculture. And they gather a lot of data, but they don't have an infinite hard drive. The hard drive is limited. They can only store that much data. They also don't have a lot of processing power. They might have some, but you need to moderate that based on the energy consumption, because the more energy, the more computing power you add. Let's say you add the GPU to have some kind of AI based analysis of data. That's fine, but it consumes a lot of energy, and because of that you might need a bigger battery, which means that the drone is heavier, which means that you need it consumes faster, and this means that the drone may not last as long. So because of that, you need to do two types of analysis. You need to do some kind of fast analysis on the drone that says maybe things like, oh, there's an object in the middle of the field, or it seems these plants don't look as they should, or there's maybe too much water because there's been flooding. And you can get this kind of analysis on the drone and get real-time alerts from that. And then the drone can send the rest of the data to some servers where you do some more analysis. Now the challenge is that the communication channel is not very stable and not very fast. They usually use cellular networks or stuff like that. So it's not that as fast as a fiber network connection, which means they can also lose connection. They might lose some data in the process and so on. So this leads to very interesting problems, and that's only agriculture. And in agriculture, at least, maybe you have a limited area and not as remote as for other types of applications, like, for example, industrial applications. So let's say you want to monitor oil pipes, and those oil pipes are going through very remote areas, and you want to send drones to make sure that the oil pipes is not going to explode, for example. And in order to do that, you might have infrared sensors and so on. But now the thing with that is maybe you need some specialized hardware that is able to analyze the data and send alerts in real time, because you want to know that if there's a fire danger in an oil pipe, you want to know as quickly as possible. But in order to do that, you might need to do some analysis. Okay, so how do you do that? Well, you do some specialized hardware, for example, FPGA. You take gates, microprocessors, basically program them to do some specific analysis and some specific alerts. And that's part of edge computing. So edge computing refers to two things. One of them is normal, let's say, processing, CPU, maybe GPU type processing, but with limited power. And the second one is specialized hardware doing specialized analysis, maybe with reduced power consumption because it's a module built for purpose, but with additional complications because, hardware is more difficult than software. So that's edge computing. And the more we'll have computers that can go into remote areas and need to give you information, the more we have the need for edge computing. There are also other cases like AI running in your mobile phone, for example, large language models that are local to your mobile phone. You can carry them there. Data does not leave from there. But that's a very specific thing. Data-driven architecture. I don't have a lot to say here. There are organizations and parts of organizations that deal with data-driven stuff. And I guess in some cases it makes sense to have this type of architecture. And then they keep saying about Dapper and WebAssembly. WebAssembly is a very interesting technology, but it's been in early adopters for a long time. That's my feeling. It is developing quite slowly. Why it's interesting? Because it offers you sandboxed environments. So WebAssembly is, if you take JavaScript and you decompose it into lower level primitives, you get WebAssembly. And then based on those lower level primitives, you can write code that runs in the browser using other programming languages. My guess is the most popular one is Rust. So you can write Rust applications with WebAssembly that run in your browser. And those applications can be games, can be engineering applications, can be all kinds of things, simulations. Now, one reason why WebAssembly is so interesting is because it's sandboxed by default. Since JavaScript runs inside the browser, it's sandbox. You cannot do certain things, like you cannot read the file from the person's file system. You can read things from the browser within certain constraints. which means that WebAssembly is a good candidate for security because it's already isolated. And it's been proven to be isolated. And you can run WebAssembly applications outside the browser, let's say, but still in a sandboxed environment. So this is why it's a really good candidate for microservices, but it's not getting as far as it could. And my guess, this has something to do with the technologies that we are using. It's not as easy to write WebAssembly code right now. Still, after many years actually of since WebAssembly was standardized and supported by all browsers. And the last one is AsyncAPI. This is a very interesting one, which I didn't know. It's standard for event-driven APIs. And it offers you tools for event-driven APIs, the ability to define them. And it's a really good idea. I think from all of these, my feeling is that AsyncAPI will be the one to move the fastest. On the other hand, I'm not sure how many companies are actually using event-driven distributed systems, event-driven microservices, for example. I know a lot of companies who don't use event-driven microservices, but they use microservices that communicate directly to one another. And they use events between larger zones or something like that. And in that case, there's not as much pressure to adopt something like AsyncAPI. But I still believe it's a really good idea. And I actually want to try it out. I find it really cool. All right. So let's see. They highlight a few of those. Let's see what they have to say. Agentic AI innovator looking past large language models to areas of innovation for AI the software architect should pay attention to are agentic AI small language models. Previously referred to as AI agents, the idea of agentic AI is to design AI models that can accomplish tasks autonomously. In some cases, multiple agents can collaborate to achieve greater results. In traditional software, we may see patterns of orchestrations or choreography to manage workflows. An agentic approach may start with agents performing specific tasks and could evolve into a supervisor approach where the AI determines which steps to follow in the business process. This approach remains an innovator trend because there is a sizable gap for companies to trust non-deterministic software to make important decisions. So I find it very funny that we trust non-deterministic humans to make decisions. We don't trust non-deterministic AI to make decisions. Now, maybe this is because we got used with computers that are deterministic. Or maybe we believe that humans are more stable in their non-determinism than AI. But it's still quite ironic. I find this ironic. Architects designing for agentic workflows can follow some of the patterns of microservices, with each agent having clearly defined boundaries and interaction patterns. These designs lead to better outcomes because the quality of responses and actions between the agents can be observed and tuned. Maintainability also improves with individual agent modules being upgradable or replaceable as newer models become available. To ensure the agent is responding appropriately, ongoing testing must be performed as either the agents or its possible actions evolve. Okay. And small language models, I think we discussed about those. Yeah, one of the advantages of small language models is they can be deployed on self-hosted hardware or edge computers. thereby eliminating network traffic latency and increasing data security, because you don't move data between to the large language model that is hosted maybe by a company that you don't necessarily trust. Retrieval augmented generation, I think we discussed about. AI assisted development, it's in early majority. Let's see what they say. Architects, when designing a system to facilitate low-code development, early extra care was usually taken to ensure the APIs were safe to use. AI coding assistants have further reduced the barrier to get started and in some way make it easy to use APIs. They may not have been intended for low-code solutions or by non-professional developers. So what they are saying is that AI-assisted development is replacing no-code and low-code, because it might be easier for non-programmers to start using AI-assisted development rather than go to low-code, no-code solutions. Although AI-assisted development may be widespread, the fact that it arrives so quickly may mean architects are behind the curve when it comes to designing systems that are prepared for the code being written to access them. Yes. This is a puzzling statement. I don't think this is the most important problem. Architects and engineers are also concerned about quality of the code produced by AI tools. Yes, even in the hand of professional developers. Yeah, because it's very variable. Because the output depends on the quality of the prompt. Not only. On the problem that you are tackling. Yeah, there are probably much more than that. Architects are finding ways to provide good prompts to help ensure coding and architectural guidelines are upheld. Okay, so now architects are providing prompts. This is news to me. Tooling is emerging to help shape AI-assisted development, but is not yet at level of the other standards for coding styles such as linting or editor config. Yeah, I understand that. Green software. Carbon efficient and carbon aware software continues to be an innovator trend to watch. Many companies focus on reducing cloud hosting costs. Yes. So this is the easiest thing to do, right? You say we reduce cloud hosting costs because that leads to less carbon emissions, and also we ask and pressure cloud companies to do their job on reducing carbon emissions, and then that's it. We don't have to do anything else, which is pretty silly, but that's how business works, right? There is far less focus on driving down the carbon footprint of a software system. Next level thinking requires architects to consider both where and when their software runs to take advantage of renewable energy. Time and location are both important factors in making software more green, because so much depends on how electricity is generated for data center. Follow the sun is generally appropriate when trying to maximize solar power. Yeah, so we discussed about this all in a separate video. There doesn't seem to be anything new. And they still completely miss on the compilation costs, but I guess one problem at a time. Privacy engineers we discuss, socio-technical architecture, early adopter. The evolution of the role of the architect and how architecture's practice is always a subject to pay attention to. Complex software systems need to be designed around the people who will build, support, and evolve the software. The shift left movement is one way this is happening, with various aspects of the software lifecycle being addressed earlier in the process. This should not be construed as a move to waterfall project management and big design upfront. Rather, architects are discussing concerns with stakeholders earlier and designing systems that are able to evolve and avoid last-minute rework to accommodate everyone's needs. Innovative architects are also trying to be less of a bottleneck during the decision-making process. Good choice. Rather than architects being the sole decision makers, the architects can help facilitate architecture decisions that are made by other teammates, by coaching them, for example, and delegating some of the decisions. By providing advice and helping others navigate the decision-making process, teams are able to move faster, make decisions that are more contextually appropriate, and have more understanding and confidence in the design. Right. I think again they are missing a big part of it, which is you need to start looking at architecture not only as technical decisions, but an ecosystem that involves people, AI. It used to be people and technical decisions. So here's an example. Let's say you have a perfect technology which will solve your problem perfectly. This doesn't exist because architecture is about trade-offs. But let's go with this example. We have a perfect technology. It solves our problem exactly as we want to. The issue is nobody knows that technology in our organization. So the architectural decision is, do we go with this perfect technology and figure out a way to solve the skill gap? Maybe hire consultants, maybe train people, maybe. Or do we decide on another technology that solves 90% of our problem, but it is supported, it is known inside the organization? So you see, the decisions are never only technical. Decisions are socio-technical, always. So this is why I keep saying that software development is a very humanistic activity. You need to take into account people. You write code for people. You implement features for people. And the people using your architecture, the developers, are people. So, yes. All right, so this is my reaction to the latest InfoQ Software Architecture and Design Trends report. What do you think about all this? Are there any other things that you've seen that are not covered here that maybe you've adopted widely in your organization in the past years? Let us know in the comments. And in particular, I'm really interested in architectural styles you're using other than microservices, and in how you are using artificial intelligence, large language models in your development process. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.